responsive. We got a smaller unit. This one's 38 kilohertz. The other one was 22 kilohertz. So we got all the way cranked all the way up. Okay, and we're only using about 1/10 of an amp and about 13 watts. 13 watts total power to produce these. Turn it down even. Got less watts, down to 9 watts. Discharge it. Let's add alright. Now let's turn it back on. Just turn it on for just a second, and the light's still going. Unplug it, so it's unplugged. Here's the plug to it. Still running. So you can get an image of our spark in there. Spark's still going. And one of the interesting things, too, you'll see our light's going still. And we'll see what it looks like whenever we turn it on. So, when we turn it on... Oh wait, I unplugged it. Anyways, we'll just leave it like that for a second. It's going. So what we'll do is we'll put our light back on so we can see what we're doing here. So basically, we'll take these two leads. We'll take our... plug, okay, we'll go on here, let me set it up. So, okay, here we go. So we're on the plug, okay, on the plug, and it's putting out 18, 19 volts out of the plug of direct current power out of the plug. So it's taking the high voltage and stepping it down to a lower voltage, and it's coming out as direct current. 16 volts. Oh, there you go. 17 volts. Slowly going down, but that's enough to charge the battery back up from what it put into it, because we only turned this on for a second, remember? We only turned it on for a second and it's still on. So energy's still coming out of there, and then we'll short it. So we'll short them out, and no effect. So turn off the capacitor. Bam! Tons of energy in there. Now let's plug it back in. So plug it back in. Turn it back on. There it goes again. Buzzing away. And there it is. It's on again. And we'll unplug it. Put our meter on it. And then the other end, we're getting 42 volts. Let's redo this, because that's pretty impressive. And this is just coming off of one of the poles. 38 volts. Now let's test the other one. 34 volts. So we're getting about 120 volts coming out, going to ground. But whenever we try to link them, we only get megavolts if we just do the 2 prongs. But if we go to the negative, 30 volts, 33 volts on both sides. So it's slowly discharging. 23 volts. So it's slowly discharging, and as you can see, the light's still on, and it'll run for a while. Let's go ahead and get our measurement for these guys. Hard to do with one hand. Well, let's just do the wire then. Ah, shoot. Come on. Okay. And that one. Oops. So it's already saying 150 volts. Overload volts. It's already saying 160 volts just being on there. And I'm touching it to the ground wire, or to metal here. Almost 200 volts DC coming off just the one end. Oh yeah, this one doesn't have the resistor on it. We haven't put the resistor on it, but it's about 187 volts DC, and it's constant. Okay. It's steady, 187 volts. Okay, well, this is a long video, and this can go up for a half hour. I actually haven't tested this small, newer, higher frequency device to see how much longer it goes than the other one. But yeah, it's definitely working. We're getting power coming out of the plug here too. So when we're plugging it in, we're actually putting DC energy back into the system, back into the grid, which is just going to ground. It's just going to the ground anyways. So that's just being discharged to ground right there. So that energy could be used. Additionally, this energy as well, that's here. Is also, let's see, well, you see it's still on, and we only charge this up for a second, but it's still going, and this is a fluorescent light. It takes a lot of energy to light that up, and granted it's not very bright. It's definitely, we need to find the best load for this, and then once we do, we'll be able to scale everything up according to the load size. So that's how it'll work. Yeah, so get an even 200 volts out of there, and it's DC, direct current energy. So we have to get another meter to test the amps coming off of it. But if we take it off of here, we can see around about 2-3 amp, and if we open it up, it's about 1.5 amp open circuit. So that's touching it. Oh, there you go. About 700 milliamp. That's about 750 milliamp is about the pressure that's putting on there. So this could be stepped down a little bit, put up a little bit more amperage with a transformer, yeah. So those are the measurements from the outside, from the output, and then the input as well. Have to be getting some better measurements on everything. I got a high voltage probe coming, but yeah. So that is basically the gist of that, and it's just a capacitor with a high frequency unit, blocking diode, a switching gap, a 71 mega ohm resistor, and a fluorescent tube light. So it's not a lot of parts either. And just imagine we step this up, we charge it up. I'm going to be seeing how I can charge up other capacitors. If I can charge up more of these all at once, maybe different spark gaps coming off. But yeah, so definitely this is really good because we got it running without it being plugged in, and for way longer than it takes to run it, with comparably more energy than what we're using to put into it. So that explains it so far. All right.